for the awesome introduction. I think I want to send that introduction to my mom, so that's going to be good. But I'll brief through the first parts of the talk. So who am I? First and foremost, I'm a Canadian. So it's woohoo! It's awesome to come back. But I forgot a jacket, so then I saw the snow and it was pretty nice. But my parents were here, so they actually bought me a new jacket. So if you want to get a new jacket, secretly go to a talk and then don't bring your jacket. So other than Canadian, I work at Facebook on M. So essentially, it's a personal assistant that uses our artificial intelligence to figure out what you want and then combines it with humans to get you what you ask of it. So you might think, wait, why is artificial intelligence and JavaScript related? You'd be very surprised how much JavaScript goes into building M. I'd say it's maybe mostly JavaScript. So that's why today I'll talk to you guys about universal applications. And if you haven't heard about universal applications, you may have heard about isomorphic applications. But if you Google search isomorphism, you'll get words like this, like formally an isomorphism is a bijective morphism. I don't know what that is. I don't know what that means, but it definitely doesn't mean JavaScript that is used in different environments. So we'll start being scientists, and we'll just use universal. And in order to feel kind of the pain that universal applications are solving, I'm going to take you guys back in time. Going back. 2015, 14, 13, 12, 11, 10, all the way to 2008. The year of Coldplay, Viva La Vida, good green tea in Thornhill, where I lived at the time, and Rails 2.2.2. So when we looked at our applications in 2008, we'd see something like this. So where is JavaScript in the application here? Is it here? No. It's not our controllers. It's not our models, not our presenters, serializers, services, all these different folders. Is it here? Kind of. It's inside of that folder. JavaScript is relegated to assets. And it's pluralized JavaScript because it's conceivable that you could just only have one JavaScript file and be fine. And when we bisected our applications at that time, we'd see something like this. The backend is handling our routing. The backend is handling our validation. The backend is handling our views. And what does JavaScript handle in 2008? Cool animations. In some browsers. This is what our JavaScript would look like. We'll add a little jQuery action here. We'll do our hello animation and put some CSS transitions in there, and we're good to go. But let's just move forward in time a little bit. I just reversed that GIF. It's awesome. To 2010, the year of Justin Bieber. And Backbone 0.1.0. Very related. So what happened here, right? What happened during the time of Backbone? Well, we started using our applications not just like web pages, but they were just as high fidelity as desktop applications, right? So if all of a sudden, every time you hit a checkbox, you have to reload the whole page, the experience just doesn't work. And when you have things like Google Map and Gmail and Mint, you really need an application that just feels like a desktop application. So the way we started doing this is we just started making a mess of jQuery, but then somebody created Backbone, and things kind of just hit the fan, right? So JavaScript grew up. All of a sudden, we have collections, we have models, we have routes. They're all written in JavaScript. And people are trying to solve this problem, trying to solve the complexity with a bunch of solutions, right? So from Backbone, we came to this. This is how many ways you can make a to-do app today using a different JavaScript framework. I actually couldn't, I had to do minus, and it still doesn't fit all of the frameworks. It's 72 different frameworks. And what we started noticing is, on the JavaScript end, you have routing, validations, and views. But on the server end, you still have routing, you still have validation, you still have views. The code is in both places. And at first, we think that we can deal with it, right? We have show.html.slim, which is the template engine for Ruby, and you might have show.jst.ejs, which is the template engine for Backbone. But then, we start thinking, okay, we can handle this. Let's say when you do validation, maybe we'll just make an AJAX request. The client will deal with it. But it just stops working that way, and it just starts exploding. Like, our app just gets complex as heck. We don't know where what is. And we still need more and more complexity to manage all this. But the question we want to ask is this just the way that things are? Right? Is it just the server and the client are just inherently different? Like, there's just nothing similar to them? Well, let's just look at it for a second, right? We have JavaScript, and we have like a server on the back end. What if we were to just change the server to something that understood JavaScript, like Node? Node is pretty fast, right? Could we do this? Could we have it so that most of our files, most of our logic is shared between those two environments? So our routing, our validation, our views, they're shared between them. Well, the first thing that we might think is, well, man, like, all my JavaScript is something like, reading from the DOM and appending onto the DOM. There is no DOM on the back end, so what are we really sharing here? What if we made our own representation of the DOM? Does that ring a bell? Anyone? React, right? So what does it mean to say your own representation of the DOM? We're essentially saying we no longer want to just imperatively say what to do on the client and what to do on the server. We're going to create higher-level abstractions that then handle that for us. We don't touch the low-level API. We don't know about how the DOM works. So if we were to do this, what would be the wins that we get? So the biggest win, as we talked about right now, would be code sharing. So most of the files you would just share, and you wouldn't have to create like models for the back end, models for the front end, and do all this magical dancing of like converting camel case into underscore and underscore into camel case and all this business. Win 2 would be perceived performance. So whenever you have a single-page application, you need to load it. You need to wait for all of your JavaScript to load in order to see the first page. But what if you were to just load the JavaScript, use the same logic for viewing on the backend, render everything, where you have control over how powerful your backend is, show it to the client, and then the JavaScript can just, as it loads, can take over, and you'd get the single-page application back again. And win 3 would be SEO. So Google does say, we got this for SEO. Even if you have a single-page application, we'll figure it out. But empirically, they just haven't figured it out. It just doesn't work. Unless they start building Selenium servers. It's just very hard to understand what's going to happen. So can we build this? How difficult would it be to create an environment that's just doesn't care about the low-level API of the client or the server? Let's do this. Let's try to build it. So first, we're going to start on the back end, and we're going to build a server using Node and Express. So what are we doing here? We're just going to build an app that takes in any route and then renders a status 200 with the text hello on it. So if we do this, boom, hello, it's on there. We're done. Goodbye, guys. Nope. What we're actually saying is, well, we just actually rendered the text hello. It's not even HTML at this point. So we're going to go ahead and add a template onto this. We could use a template language, but really, all we really want to do is just wrap this in an HTML tag so we can use template strings in HTML. So all this function will do is it'll take in any string, and then it'll it'll put it into the string that'll essentially be our HTML. So we'll add it into our app function. We'll go ahead, and now we see that the title is there. We're rendering HTML. So what's left? Well, we haven't started yet. The biggest thing is we need to add React. We need to start building our application. So first, we'll create a little app, and all the app is going to do is it's going to return an H2 element that says, "Welcome to Stopa's blog." So what we'll do is because React just renders a virtual DOM, we can just render that on the client and on the server. On the client, it'll output out DOM nodes, and on the server, it'll output out strings. So React DOM actually has a function called render2string. So what we can do is instead of sending back hello, we'll use render2string and send back whatever React thinks is the result of compiling app for the first time. So if we were to do this, boom, welcome to Stepan's blog. We're now rendering React from the server. But this is still not a single-page application. What will happen if we add an on-click handler onto that H2 element? Anyone? What do you guys think will happen? We can see. So we're going to do localhost. We click it, but nothing happens. Well, because we just rendered to string and we sent that out to the client, but we don't have a client JavaScript file, right? So now we're going to go ahead and do that. This is how our template used to look like. We would just send out whatever React thought to be the HTML element. But what we could do instead is we could also send in a script tag which says, whenever I load this page, I actually go ahead and request this client.js file. And then we're going to wrap our body into a root element so that then our client.js file can start building on top of this. So how can our client.js file look like? Well, we would just take in React, we take in React DOM, and instead of writing render to string, we would just write React DOM.render. And then we would pass in app, we would find the element root, and then it would replace it. So this would be, well, let's see what will happen if we do this. Oh my God! So what just happened? The server rendered what React produced, sent it to the client attached onto it, and then continued on as a single-page application. This is all cool, but we're still just really rendering an H2 tag. Well, let's make the app a little bit more complex. Actually, before that, we figured out the views are now shared, but what are the costs? What's the catch? Is it really that simple that does it really take 2 minutes and a few slides to make this work? Well, there's build tools. So usually you don't need build tools for Node. But if you're rendering JSX in Node, you do need a build tool. And if you want to use import instead of require in Node, you still need a build tool. So what you'd need to do is there'd be an upfront cost. So you'd have to use Webpack and Babel and the family of builders for both the client and the server. This is why people talk about JavaScript fatigue and all this business. But really, it's just one sunk cost. So you spend like a week, you get really frustrated. But at the end of the day, all of your engineers will then need to only learn one way of doing things. And it really will be just the same throughout environments. So now we have our app. Let's make it a bit more complex. So what if we want to add routing? On the client side, how would we figure out what route we need to render, right? What component? We'd have to use window.location. But window.location doesn't exist on the backend. So now, again, we need some sort of library to abstract the difference between the client and server. And one thing that we could use is React Router. This is probably what everybody that uses React uses. And what React Router will allow us to do is it'll allow us to declaratively define our routes, and then we'll leave it up to it to know when to change push state and when to render the correct component. So let's do this. The first thing we're going to do is we're going to disable server rendering for now and just make it work on the client side. So we'll just see how React Router works if you had a normal single-page app. We just removed render to string. So all we're doing now is we're just going to render an empty HTML document, and then client.js is going to start taking over. The next thing we're going to do is we're going to change our app a little bit. So we have our cool welcome to Stepan's blog with a nice alert on click. And we're going to change it up. So this is a whole app. Look at that complexity. So we have a header component, we have an about component, we have a contact component. And the about and contact component will be rendered via this.props.children through React Router. So we'll look up and we'll create this routes file. And the routes file is going to define the routes for React Router. So we'll just say that the home path is going to render app. The index is going to render the about page. And if you go to /contact, it should render the contact page. So now we have, this is how client.js used to look like. What we'll do instead now is we'll import routes. We'll import a few magical things from React Router, so router and browser history. And instead of rendering our app, we'll just render the router. And on the client side, we should be pretty good. So if we run our site now, oh, wow. Ooh. The browser is changing. Wow, OK. So we made it to step 1. But what will happen if we disable JavaScript? We don't have server rendering right now. So if we do that, that's it. So it doesn't work, right? Cue the silence. But we can make it work. So this is how our server looks right now. Because we're using React Router, we can then take in some of its functions on the backend as well. So we'll use match and router context. And what we'll do is whenever we get any URL, we're just going to feed that into the match function of React Router. And it's going to give us the props, the amount of components it needs in order to render the page. So we'll do that. We'll, in our callback, send in the router context with the correct props. And now we'll have universal rendering on the client and on the server. Let's see how this works. Home, contact. Nice. And just in case, yes, JavaScript was disabled at that moment. So we've now built an app that does routing. It's universal, both for routing and for rendering our views. But our app just doesn't just route between different pages that's already known to us, right? What about data fetching? The first thing about data fetching is, maybe this is what we would have had in the age of Backbone. We'd use Ajax and we'd get the page. But the problem is Node doesn't have XHR, so we still need another abstraction that can separate out the idea of how to make an Ajax request. Q isomorphic fetch, which essentially for the client it uses the fetch API. For the server it uses Node's Ajax API. So now we're able to make these Ajax requests from the client and from the server, but we still need to know when we need to make the requests. Right? When we render the blog page, we need to get the posts. When we render the about page, we need to get some dynamic about me data. So the way that we can do that is we can actually just add a static function on fetch data, and we can on any React component, and then based on the route that we render, we can actually just traverse our components and then figure out what data we need and make the request to get that data. So here's how we would ideally want to do it. Instead of just sending back the router context immediately, we would create a fetch all data function that would take in all the components. It would filter out anything that doesn't have fetch data. It would make the request for fetch data and then would await for all of those requests to complete. Then what we could do is we can just say, fetch all the data, and afterwards return our page. So why are we blocking here? Well, because the server should be able to get all the data much faster than on the client. So if you're in different environments where making many requests is not a good idea, it's probably better for you to make the initial request on the server, send everything to the client, and then the client can just continue on doing its business. But the thing is, though, so now that we have all this data, on the client side, we also need to have the same data, the initial one at least, right? So what we could do is we could update our template. So instead of just taking in a body, which would be the React component, or the React rendered string, we'd also pass in the initial data that we just computed. So we can say, whenever this page loads, set a global data object for all the data that we just initially got. Then, in our client.js, we can use that initial data object and feed it into our React application. Here I'm using something like create store. Probably the reason I'm not explaining much more about what way that you should use, what type of data management library you should use is there's another talk about Redux, which will explain all of this. But the idea is you take that initial data, you feed it to the client, but then whenever the data changes, you still need to re-render your app. So you'll need some sort of event emitter. So some sort of store library could solve this for you. And then we would just, this is how we used to render on the client before. But what we want to do is now that we're on a component, we want to make sure if we go to a different page, we still fetch data for that. What we could do is, wouldn't it be nice if there was like a create element function that every time we created a new element, we could check if it had a fetch data property, then run the fetch data property, and then return out the component. And the fetch data property would run asynchronously. Because we're on the client, we don't want to block on the client. So thankfully, React Router actually also has this for you. So you can give it a create element property, and then every time it changes the route, it's going to run create element. It'll get the fetch data. It'll hydrate your store or fill in your store with that information, and then you'll be good to go. So the reason I showed you how to do this, and it might have been a little bit confusing, is because whenever we talk about, like, I'm introducing all these libraries that'll separate the logic between the server and the client. But actually separating those libraries is not that difficult, right? Like, that's how you would do it for async data. And again, there's already a library for that. So you don't actually have to do what I just showed you with fetch data. You could use something like React Resolver. But nevertheless, this is exactly how you would do it yourself if you wanted to. And invariably, when you build a large application, obviously there'll be something that doesn't have a library for it. So is it all rosy? If you do all of this, do you have an application that's just supremely fast? All your engineers are happy, everything's good? No. It's not all rosy because really the environments, there's the low-level API is not the same, and not every library is being written everywhere about how to handle all these different type of cases. And you'd have to think about, the more complex your app is, the more you'll start realizing, oh, like, I need cookies, and then cookies are not the same on the client, and they're not the same on the server. Maybe you don't want to make AJAX calls on the back end. So there will be an upfront cost, no matter what. There will be many libraries, but you still have to pay one. But the upside is just ridiculous. So let's see, we were considering this as the case, right? We have the client and we have the server. But let's move a step back here, right? We're not just considering the client and the server. There are many different clients. There's a client for Android. There's a client for iOS. We just saw the talk about React Native. If we're to build our applications declaratively, and we build modules that can separate the code for the difference between each environment, then we can just take everything over and write code that just works everywhere. Imagine the happiness of your engineers. Everything's in a repo, right? If you want to learn how to do iOS, you just tab out, run npm, and all of a sudden iOS is working. You tab in, you run your server, everything's working. So this is the big upside. The only other downside that somebody might think is, man, I'm a multi-threaded programmer. Like, single-threaded backend? Jesus. What are we, like back in 1999? Well, you don't have to use Node, right? So JavaScript has become so fast, right? Our engines have become so fast that they can become a render target. They can become a compile target. So there's many languages now. If you're a Clojure fan, you could write Clojure on the back end that renders onto Java. So you get your multi-threaded magic. And you can write Clojure on the front end that renders onto JavaScript. And you'd still be able to share most of your code. And this isn't just Clojure. There's Scala.js. People are doing this for Haskell, I think. So the libraries here are pretty immense. So that's it. I think there will be a bunch of questions. The idea here is if you write code that is not that doesn't have to deal with the environment that you're writing code on, you'll have a lot more power as an engineer, and you can move a lot faster.